In this problem, we're talking about a typical communication satellite that uses a handheld sat phone. So these satellites are in low Earth orbit. There are a lot of them. They have to be. It's kind of like you drive. It's kind of the opposite of you driving down on the road with your cell phone and you're being handed off to cell tower as you move. The opposite is happening here. The satellites are moving and the satellites are handing you off one to the other as they go overhead, picking up on your sat phone. They have to be pretty close because if they're not, you're not going to have the power to reach them. You're not talking about a directional antenna, you're not aligning anything, you're just picking up one of these big brick-looking phones and holding it and walking around and talking. All right, so this satellite is 195 kilometers above the surface. And you need to know how big the Earth is because the satellites don't orbit the surface, the satellites orbit the center of mass of the Earth, and so they go around the whole Earth. And so their orbital distance is the sum of these two, right? 194.5 kilometers plus 6,371 kilometers. And you'll need to multiply by all of this times 1,000 meters per kilometer to get to the right units. And now we know that. We know the mass of the Earth because it's given to us here. We just need our orbital velocity equation. Gm over r. R is just this number in meters. M is the mass of the Earth or whatever object you happen to be orbiting around. And G is the universal gravitational constant you're given here. Right? And it's capital G, not little g. And so at this point, you just plug everything in and you calculate. And that's it.